Hello, students and other viewers. Here I have developed a quick revision multiple choice question for reheat and regenerative feed Rankine cycle, helpful for government, private job competition exam, and for particularly for interview in power generation industries. So this is actually the MCQ. So knowledge of reheat and regenerative feed Rankine cycle is a prerequisite before going through the video. And the topics covered are reheat in Rankine cycle, regeneration in Rankine cycle. There are numerical also and genuine question. No AI is used. Okay, and you can do this activity also. Okay, award one for each correct answer, and at the end find the difference of the marks. Okay, so if there is no difference, you are a genius. So let's start. The purpose of reheat is in Rankine cycle. Purpose of reheat to keep the quality dryness fraction of steam in safe limits for turbine, to enhance the efficiency of Rankine cycle, both 1 and 2, to increase the number of turbines. What is the correct answer? The correct answer is to keep the quality dryness fraction of steam in safe limits for the turbine. In Rankine cycle, there is a turbine. So when steam enters, the dryness fraction, it means wetness of steam must be in control. So the purpose of reheat is mainly to control the dryness fraction. You might be thinking that this answer 2 is also correct. So both 1 and 2 must be correct. So I would like to tell you that by the help of reheat, it is not necessary that efficiency will increase. In case not performed properly, the reheat can even reduce the efficiency. However, the sole purpose will be solved, that is the dryness fraction of steam will be in safe limits or in control before entering to the turbine. Now, what is considered the safe limit regarding the dryness fraction of steam for a steam turbine? Greater than 85%, greater than 80%, greater than 90%, greater than 98%. So, what is the safe limit for turbine? The answer is 85%. Okay. So the dryness fraction of steam before entering the turbine and anywhere in the turbine while expansion, the dryness fraction must be greater than 85%. So this is the safe limit. Otherwise, it can damage the turbine peripherals, especially the blades of the turbine. Reheating in Rankine cycle increases the cycle efficiency. True, false, maybe none. The answer is maybe. See, I already told that by the help of reheating, mainly we control the dryness fraction. The efficiency can increase, can reduce also, depends that the reheating is performed properly or not. The net work output in reheat Rankine cycle is more compared to no reheat. So what is the answer? True, false, maybe none. The answer is true. So actually, in reheat Rankine cycle, the number of turbines increases. 1, 2, or 3. High pressure turbine, intermediate pressure turbine, and low pressure turbine, like this. Okay. So due to increment in number of turbines, the total work increases. Okay. But efficiency will depend that properly the reheat is performed or not. Okay. So this is true. Normally, the maximum number of reheats in reheat Rankine cycle could be, means how many reheats are possible. See, what is reheat? I will tell you. It is like this, that this is the boiler, and from the boiler the steam is coming out, as I am showing by the help of this cursor. So entering the turbine, this is a high pressure turbine. So when steam is expanding and when the dryness fraction falls below 85% or below safe limits, the steam is taken out and again sent back to the boiler. Over there, the heat is added so that again it is superheated and dryness fraction could be 1. Then the steam is coming out and it is expanding in a low pressure turbine. So it is expanding ultimately after performing its job. It is coming out from this low pressure turbine LPT and then to the condenser pump and then boiler back. How many such turbines can be implanted? Here it is single reheat. You can see from high pressure turbine it is coming out. Once it is reheated and sent back. So this is one reheat. So can we perform one more reheat? The answer is yes. Maximum 2 reheats can be possible. In that case, 3 turbines will be there. High pressure turbine, intermediate pressure turbine, and then low pressure turbine. Okay. So maximum 2 reheats can be performed. Okay. Consider the following data for reheat Rankine cycle. The low pressure turbine work 50 kJ per kg. The intermediate pressure turbine work 50 kJ per kg. The high pressure turbine work 300 kJ per kg. The pump work is 50 kJ per kg. And net heat input to the cycle is 2500 kJ per kg. What is the efficiency out of these? Can you calculate? The answer is 38%. How? For Rankine cycle, the efficiency is given by total turbine work minus total pump work upon the total heat input. So what is the total turbine work? That is 350 plus 350 plus 300 return. What is it? Pump work? It is 50 kilojoule per kg return upon 2500. So if we will calculate, it will come out to be 0.38. So the answer is 38%. Now, the main purpose of regeneration in Rankine cycle is to boost the net work output, to improve the cycle efficiency, to improve the steam quality, 2 and 3. What is the correct answer? The answer is the sole purpose of regeneration is to improve the cycle efficiency. The regeneration has nothing to do with the steam quality or network output. Actually, network output reduces in regeneration. However, the cycle efficiency increases. Consider the following statements and choose the correct one. The net work output in regenerative Rankine cycle reduces. However, the net heat input also reduces to improve the cycle efficiency. The net work output in regenerative Rankine cycle increases for net heat input to improve the cycle efficiency. The net work output in regenerative Rankine cycle reduces. However, the cycle efficiency enhances due to lower work input to the pumps. None of the above are correct. What is the correct answer? The correct answer is first one. Means the net work output of regenerative Rankine cycle reduces. It is contrary to that of reheat, in which the net work output increases. Here it is reduces. However, the net heat input is also reduced. Due to that thing, the efficiency improves. So, first one is the correct. Normally, the maximum number of steam blades can be taken for regeneration in Rankine cycle for improving the efficiency are means total for the purpose of regeneration. Actually, steam is taken out from the turbine casing called a steam blade. Okay. So, how many steam blades can be taken out in totality? Means if we are crossing that number, in that case, the efficiency will start reducing. Okay. So, two steam blades, four steam blades, nine steam blades, 11. So what would be the correct answer? The correct answer is 9. So 9 steam blades points can be taken from there. The steam can be taken out for the purpose of regeneration. And in case we are going beyond 9, the number of pumps increases. So whatever efficiency we have gained by applying regeneration, the same efficiency is reduced due to work input to the pumps. So maximum we go up to 9 steam blade points for regenerative feed Rankine cycle. With increasing the number of steam blades in the regenerative Rankine cycle, what of the following increases? The dryness fraction of steam, the number of pumps, the heat addition in the boiler, none. So I already told, in this case, more the number of steam blades are there, more the number of pumps will be required. So this is the correct answer. Choose the correct statement regarding regenerative feed Rankine cycle. The open feed water heater has higher effectiveness than closed feed water heater. The open feed water heater has lower effectiveness than closed feed water heater. The open feed water heater has equal effectiveness to that of closed feed water heater? None. Which is the correct option? The correct option is first. Open feed water heater means what? The steam that is taken out is directly mixed with the liquid water. So in this case, the heat transfer it is higher compared to that of closed feed water heater, in which what happens? The steam gives up its heat to the liquid water by heat exchanger mode. Means the steam doesn't mix up with the liquid water, just heat is transferred. So remember one thing, that open feed water heater has higher effectiveness than closed feed water heater for the case of regenerative feed Rankine cycle. Now there are some numerical. If 1 kg per second of steam enters the turbine, it expands the turbine with a specific enthalpy drop of del H1. Means when it is expanding in the turbine, del H1 is the enthalpy drop. And after this, mkg per second steam blade is taken out. Means when del H1 enthalpy drop has took place, mkg per second of steam blade is taken out. And then remaining steam, m is taken out. It means what? 1 minus m. Amount of steam further expands the turbine. The remaining steam expands till the condenser inlet. Means after that it expands up to the condenser in the turbine itself with a specific enthalpy of del H2. Means between these points, after del H1, the next enthalpy drop, specific enthalpy drop is del H2, and the amount of steam expanding further after this 1 kg, it is 1 minus m kg per second. What is the total turbine work? Go through these expressions. The correct answer is 1 into del H1 plus 1 minus m into del H2. The reason being that steam is entering with amount 1 kg per second. Okay, so up to some point of turbine, the specific enthalpy drop is del H1, that is in kilojoule per kg. So up to that much expansion, the work done is this. Further m kg per second of steam blade is taken out. It means further expansion is of only 1 minus m kg in the turbine, and the specific enthalpy drop further is del H2. So 1 minus m into del H2. So this is the total work output of the turbine in this case, and you can see why the work done is lower compared to that of no regeneration is employed. Reason being that full 1 kg expansion doesn't take place through the entire turbine. For some extent it is 1 kg per second, and then further, since some steam blade is taken out, so further expansion is of lower steam. So this is the correct. Now if 1 kg per second of steam enters the turbine, it expands in the turbine with a specific enthalpy drop of del H1. Means the same question, some data is different. Then m kg steam blade is taken out. The remaining steam expands till the condenser inlet with a specific drop of del H2. If the specific enthalpy drop in the condenser is HFG, what is the heat rejected by the condenser? Now, the question is that after doing work, when it is passing through the condenser, then how much heat is rejected? Simple. Since m kg per second of steam blade is taken out from the turbine itself, so up to the condenser, the amount of steam reaching is 1 minus m kg. So 1 minus m kg is reaching the condenser. So 1 minus m into HFG is the total heat loss rejected by the condenser. So this is the answer. If 1 kg per second of steam enters the turbine, it expands the turbine with specific drop of del H1. In same question, some data is different. Then m kg steam blade is taken out. The remaining steam stands till the condenser inlet with specific enthalpy drop del H2. If the specific enthalpy added in the boiler is del H4, what is the total heat added in the boiler? Now the question is that in the boiler, how much heat is added? Out of these four, the correct answer is del H4 itself. The reason being, see, if from the boiler 5 kg steam per second is coming out, then definitely 5 kg per second water has to input because it is steady flow. So the at the boiler inlet and at the exit end, both end will have same amount of fluid flow rate because it is steady flow process. So if from the boiler 1 kg per second of steam is coming out, in the first sentence it is written. So in the boiler the total enthalpy rate is del H4. So del H4 into 1, which will give del H4 itself. Now consider the following assertions. Regeneration enhances the efficiency of Rankine cycle. In regeneration, the amount of heat rejection is reduced in the condenser by sending low mass flow rate of steam to it. These are the two assertions. Now, assertion A is correct. However, assertion B is not correct. Explanation of assertion A. Assertion A is correct and assertion B is correct. Explanation of assertion A. Only assertion B is correct. Both the assertions are incorrect. What is the correct answer? The correct answer is assertion A is correct and B is correct. Explanation of assertion A. So what it says that regeneration enhances the efficiency of Rankine cycle. I already told. And in regeneration, the amount of heat rejection is reduced in the condenser by sending low mass flow rate of steam to it. I already told this thing by the help of a numerical. Here you can see. Already told that through the condenser, the total amount of steam reaching is 1 minus m kg. M is already taken out for steam blade. Okay. So if less steam will go toward the condenser, lower heat rejection to the atmosphere, then from the entire system, lower heat loss to the atmosphere. So it enhances the efficiency of the system. Thank you.